Hello everyone. In today's session, we will be continuing with basics of coordinate geometry and the second part. In first part, I had just introduced you the Cartesian system mainly. Now, the first thing what comes here is section formula. Now, section formula means that we have not done something like this in plane geometry, so we need to take it separately. Now, if 2 points are given to you, say A and B, their coordinates are say x1, y1, x2, y2, and there is a point P which divides the join of A and B in ratio m1 is to m2, where m1 and m2 I am taking positive. Now, when I say this, I don't know where that point P is. So there could be actually two types. One is internal division. That means point P is between A and B. And then how do we find coordinates of point P? That means point P divides A and B's join internally in the ratio m1 is to m2. Picture would look something like this. That I have written m1 between AP and I have written m2 between PB, and I'm saying P divides AB internally in ratio m1 is to m2. And then the formula is x equal to m1 x2 plus m2 x1 upon m1 plus m2, and similarly I can write y, coordinate of point P, as m1 y2 plus m2 y1 upon m1 plus m2. That gives you coordinates of point P, that is x and y. Now, please do not remember this formula as only that it will be giving you coordinates of point P. It could be other way also. Point P is known to you, B is known to you, you are asked to find point A or maybe point B. So realize this, the way you wish, you can use this formula. Next type could be external division. For external division, we expect point P to be outside. Outside means how would it look? That I have extended AB and further somewhere comes P. Not necessarily that you have to extend AB in direction of B. It could have been the other way also, but frankly, which point is called A or which point called B, that is left to us only. So, I'm just showing one picture that AB extended to P. Then AP is to PB. That ratio is actually M1 is to M2. So, point P divides AB externally. Picture is something like this. Now, what would be coordinates of point P? X is given as m1 x2 minus m2 x1 upon m1 minus m2, and y coordinate is given as m1 y2 minus m2 y1 upon m1 minus m2. Now, frankly speaking, external division formula, since it is given in the book, so also I am writing here. But frankly, all my life, I didn't use external division. If you wish, you can convert the problem of external division to the internal one only, thinking point B divides internally AP, and you can further proceed. Finally, you are asked to find coordinates of point P, and that would come in terms of x and y as written here. Okay, let us proceed further. And the next one is the illustration, which comes by default. And the illustration is point A is given as 2, minus 3, point B is given as 5, 6, and point P divides segment AB internally in the ratio 2:1, and we are asked to find coordinates of point P. Simple application of formula. Picture would look something like this. A is 2, minus 3, point B is 5, 6, ratio AP to PB is 2:1, and then you have to apply formula to get x. 5 into 2 plus 2 into 1 upon 2 plus 1, that gives you x, and similarly you get y also, that is 2 into 6 plus 1 into minus 3 upon 2 plus 1. So answer for x would be 4, and for y answer is 3. So point P is given as 4, 3. Simple application of formula. One example should be sufficient to understand how we apply the formula. Let us go to the next one, and that application now expected to be of external division. Now, point A is given as minus 3, 1, B is given as 4, 7, and point Q divides segment AB externally in the ratio 3:2, and we are asked to find coordinates of point Q. So, point Q I name say as x, y, and then picture would look something like this, that A is minus 3, 1, B is 4, 7, Q is not known to me, but AQ is to QB is given as 3:2. Now apply formula and get x as 18 and y as 19 just by simple substituting values of m1, m2 and coordinates of A and B. We get point Q as finally 18, 19. Now this was one example on external division. Let us proceed from here and go to next. And next one is now important notes. Because if you remember them as important notes, then you will never make mistakes while solving problems. First is that if m1 upon m2 or m upon n, that ratio given is positive, that means point actually divides internally. And if m upon n or m1 upon m2, in my first part I said m1 upon m2, so I'm saying m1 upon m2, or ratio m is to n is given to be negative, then point divides externally. And the coordinates of midpoint can be obtained by internal division formula. Here m1 and m2 both would be 1 and 1, and hence midpoint is given by x1 plus x2 upon 2 and y1 plus y2 by 2. They are the x and y coordinates of midpoint. And now one more formula I would give you, which you can remember separately. That is the centroid of the triangle. This is very, favorite question on centroid most of the time in coordinate geometry. So centroid formula also you can remember. And centroid formula also has been derived. The entire derivation I am not giving you here, but actually that has been derived using the internal division and nothing but your this midpoint formula only. Now, x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, they are the x and y coordinates of the centroid, where x1, y1, x2, y2, x3, y3 are the vertices of the triangle. Now, these are simple formulae, midpoint formula and centroid formula, which you can keep in your notes right from beginning. Here, further if we move, we want one more application to be taken, and that is nothing but of area of a triangle. Now, when I say area of a triangle, obviously some coordinates are required, coordinates of the vertices. They are x1, y1, x2, y2, x3, y3. Then how do we write the area part? And area, I have written it as 1 by 2, and then I'm using two, standing lines, and I have written there x1, y1, 1, x2, y2, 1, x3, y3, 1. In 3 rows, I'm writing quantities. This is called a determinant. When we do determinant as an application of determinant, perhaps we may do it again. But those who are not aware of the word determinant, they can actually write the entire expression. It is 1 by 2 into x1 into y2 minus y3. You try to remember only the first part, x1 into y2 minus y3. Remaining two terms you can write cyclically. That would be x2 into y3 minus y1 plus x3 into y1 minus y2. So don't get perturbed because of the length of the formula. You just try to remember the first one, and cyclically you will be able to write the remaining two terms. So area of a triangle you can find using formula. Now, certain things are to be told about area of triangle where students tend to make mistakes, which I am writing here in important notes. First is that area of a triangle, if it turns out to be 0, ABC must be collinear, so don't get perturbed. And second one is area of a triangle is generally expected to be non-negative. If you are getting that as negative, that also says something. Actually, points A, B, C are to be taken in anti-clockwise direction. In case you have taken clockwise one, or if order of ABC is not taken properly, then there is a possibility that you get area as a negative quantity. Don't get perturbed by seeing the negative quantity. Finally, you can of course take absolute value and finish the problem. I think this is good enough for this second session. When I come next time again with something new. Hope you enjoyed the session. If you have liked the video, please click to subscribe on this side. And if you want to place the order for the book, please click on this side. Thank you.